This IoT project is a collaboration between Nebulous Systems and the Stevens Institute of Technology. We founded Nebulous Systems with a very specific mission: to tackle with a niche problem related to universities with STEM programs and technical and vocational education centers, and this project pushes the idea even further. But first, what is the original problem exactly? Well, these educational institutions need to provide lab practices to students, right? However, labs have not evolved for the last 30 years, and this means there is room for improvement. First, lab equipment is very expensive. We can confidently say the equipment cost is above 100,000 euros in any lab room. This means universities do not have all the equipment or lab setups they might want to have. But it is even worse, because expensive as it is, lab equipment stays idle about 99% of the time due to teachers' schedules. So the bottom line is, institutions spend lots of money in labs and still the students are able to only use them marginally. This brings us to our solution. We propose an ecosystem of solutions that include a cloud IoT platform that allows managing and providing remote access to lab resources. So we convert traditional labs into smart connected labs. The advantages for our clients are many, but I would highlight 3 of them. 1, it allows to provide more lab time to their students. 2, it saves money to clients because they can borrow other institutions' lab systems they may not own. And 3, they can even earn money by renting their lab resources through a controlled remote access. Unfortunately, smart and online labs are not that easy to develop or share, until now. In this project, we worked to make online labs as easy as snapping your fingers. We identified 2 main problems when evolving traditional labs into smart connected labs. The first one is the effort required to develop the web applications that enable the remote operation of the lab systems from the internet. The second one is related to sharing the online labs with other institutions. For the first problem, we have developed a system that automatically builds the web HTML5 applications. This is done by using a combination of the metadata received from the smart labs and intelligent web design methodologies. In the future, we plan to extend this by allowing users to manually modify the user interface and save the results. Finally, machine learning will be used then to train an algorithm that would further improve the automatic generation of web applications. For the second problem, we have prepared a smart contract that can be deployed into the Ethereum network. This contract handles all the relevant aspects in online lab sharing, such as the information of the lab owner and the institution that want to access it. We also created a web app that interacts with the smart contract, but thanks to the decentralized nature of blockchain, anyone could develop their own web app for their specific purposes.